All right, today we're going to review the quadratic formula. So as you remember from last year, the quadratic formula helps us to find the solutions, the zeros, or the roots of a quadratic equation, just like factoring does. Like if you factor a quadratic equation, you set equal to 0, and you find the zeros of each factor, those are your x-intercepts. But a lot of times it can't be factored, or sometimes it can't be factored, and you could use this formula. There are even some countries that don't learn factoring at all, like we do in America, and they only use the quadratic formula because it works in every single case, even if it could be factored. But we are going to be using this also to draw a sketch of the graph, because a sketch of a graph of a quadratic would include, and I have them up there, the zeros, the vertex, and the y-intercept. So the zeros we can find from using the quadratic formula. Now, in my algebra classes, we're also talking about, this is the first time they've seen it before. So we look at this formula and we see, what about this do we recognize? Now, they just learned completing the square. And when you complete the square, you have to solve it. So there's like the plus or minus, because you have to take the square root. So they sometimes point out the plus or minus. But is there anything else in this formula that is related to things that you learn in algebra about quadratics and parabolas? Raylan, what were you going to say?
The AC, you multiply it when factoring as well, but that doesn't have anything to do with quadratic formula.
Yeah, there's a way to prove this formula, but I'm not 100% sure where the AC is off the top of my head, or what the AC does. But what else, maybe? Is there any other part of this formula that you use when you graph a parabola? Because that's a better question. Grayson? Oh, actually, no, you cannot, because you can't get rid of the a and the square root because it's under the square root, and you can't cancel something out that's in a square root that's not in a square root. So yeah, you cannot do that. And what else? Negative b plus or minus blah 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 over 2a. Negative b thing over the 2a, right? So this part gives you the vertex, the x-coordinate of your vertex, or your axis of symmetry. So they remember that because they've used that to find the vertex and the axis of symmetry. But that's when we use this formula, we'll also be looking at that part to help us find the vertex. So when you do these problems in your homework, I don't want you to rely on a graphing calculator. Don't type it into your y equals. I just want you to learn how to do it this way. I told the other class yesterday, that one of the things that they do in Algebra 2 is they make you take some quizzes without a graphing calculator, so that you know how to not rely on your graphing calculator and actually do the math yourself. So we're going to practice doing that. Now, you can still use your calculator to type in the numbers and find the decimals. But also, in what we talk about with algebra students is that there are three situations. A parabola can cross through the x-axis twice. It can cross through it once, like it can just touch it like this and come back up. Or maybe it doesn't have any solutions and it doesn't go through the x-axis at all. So those are three different types that we're going to cover today. So the first one is quadratic equations with two solutions. So first step is to put it into standard form and make it equal to 0, because we're finding the zeros of the function using this quadratic formula. And then identify your a, b, c, plug it into the formula, simplify, and get your answer. So our a is 2, our b is 1, and our c is -5. So when I write my quadratic formula, I like to write x equals and then a big fraction bar. And we're always going to show our work. Okay, so we're not just going to type it into our calculator off the bat. We're going to show our work so that we can fix something if it's wrong. And then negative b is -1, so it's -1 plus or minus the square root of b squared, which would be 1 squared, minus 4 times a times c, which is -5. All over 2a, which is 4. Now what I like to do first is simplify my numerator. So if I simplify the numerator, you would get 1 Since there's a minus and a negative, I see two negative signs. Those cancel out to plus. And then 4 times 2 times 5 would be 8 times 5, which is 40. So the discriminant, the number that's under the square root, is 41. So this would be negative 1 plus or minus the square root of 41 all over 4. And one thing you can do, and that we know how to do because we've covered simplifying square roots, is you can separate this equation into two different fractions as negative 1/4 plus or minus the square root of 41/4. And sometimes you can separate it even further. But if you're just worried about getting the decimals, you could type that into your calculator, like this part into your calculator, and get the decimals. I'm just showing you that you can separate it and that this would be a valid answer. Like if you were only answering the question, you could do it without a calculator by just doing that. If you're graphing it, you'll want to type it into your calculator to get the actual x's, like the decimals, so that you know what the decimal part is. Okay, but anyways, let's take out our calculators. And let's type in, I'm going to use my fraction bar, negative 1 plus square root of 41 divided by 4. There's no plus to minus button in your calculator. You should know that. And I get 1.35. The other one, actually, if I just go up and press enter to copy it down, I can change the plus to a minus sign. Gavin?
Mine says error.
Okay, what's the error message? Say syntax error. Did you type in a minus sign instead of a negative sign?
Yes, this is error syntax.
Yeah, you typed in a minus sign instead of a negative sign.
Also,
Okay, so I got 1.35 and negative 1.85. So x equals 1.35, x equals negative 1.85. Those are your solutions, which are your roots or your zeros, and your x-intercepts. Solutions, x-intercept. So if we graph it, those would be the points on the x-axis the parabola goes through that make the y equal to 0. But next, we're also going to find the vertex. So remember, the vertex, the x-coordinate of the vertex is that negative b over 2a part, which is right here. Negative b over 2a would be negative 1/4. And then to get the y-coordinate, you would plug negative 1/4 back into x. So go ahead and try doing that. Alex?
Calculator, I got 0.6.
Okay, you probably didn't put parentheses around your numerator.
Oh.
So you did one of the fatal errors of not putting parentheses around your numerator. So, not to call Alex out, but so that you don't make the same mistake. Do not do this. Negative 1 plus the square root of 41 divided by 4. Because all that's doing, order of operations, it divides the square root of 41 by 4, and then it does the minus 1. Okay? You need to do the numerator first and then the denominator, so you have to put parentheses around it, or just use your fraction button if you have one. You plug the negative 1/4 back into x of the original equation. We're using our original equation. All right, so you got the 2 there. I'm going to put parentheses around my x because it's negative and I'm squaring it. So negative 1/4 squared plus the x is negative 1/4 minus 5. We're finding the y-coordinate of the vertex. We know the x-coordinate of the vertex was negative 1/4 because that's the negative b over 2a part of the equation. Okay, syntax error means you're putting a minus sign instead of a negative sign. Or maybe you have like plus and then a minus sign. You can't have plus and then minus. It has to be plus and negative. Okay. So this right here, I'm going to put it in a cloud. This will help us on the next page when we are graphing this. Let's just do the graph right now because the other class was confused because we did the graph later at the end. So flip your page over. This equation is actually the third column because if I subtract these guys over here, I get 2x squared plus x minus 5 equals 0. So that's the same one as the third column. So the discriminant is the number that's under the square root, this b squared minus 4ac part. Our discriminant was 41. That's the number we got under the square root. Since it was positive, we had two solutions because we had a plus square root of 41 version of our answer and then a minus square root of 41 version of our answer. So there ended up being two answers. That's how most of your homework is going to be. It's going to have two answers. And then let's draw a sketch of the graph. So our sketch should include those three things, the zeros, which are the x-intercepts, the answers that you got for x, the vertex, which comes from the negative b over 2a, and then when you plug it back in, and then the third thing, if I can click on this, there we go, is the y-intercept. The y-intercept is given by the c part of the equation because it's when x equals 0, so all you're left with is the c. In this case, it was negative 5. So I'm going to draw an x and y axis. Our zeros were 1.35 and negative 1.85. So I need to go over two spaces on both directions. I need to go down 5. 1, 2, 3, 4, 5. On your homework, I will give you some graph paper that you can use.
Thank you for your ability.
You're welcome.
Yeah.
All right. Now we're going to plot. The first thing I always do is I plot the zeros. So the zeros were 1.35, so kind of in the middle, a little closer to 1, and negative 1.85 towards the negative 2. And then I'm going to plot the y-intercept or the vertex first. The y-intercept was negative 5 because c is negative 5, and the vertex is just a little bit below it on the left because it's negative 1/4. So you just go over a little bit and then down a little past negative 5. So those are the 4 main points that you need. And then you can connect them. You could use your calculator to check your work, but you still need to show all your work. Grady?
How did you find the discriminant?
The discriminant is just the number that's under the square root. We already found it. It was 41. Remember how we simplified it?
Yeah.
Now, that part is not like super important that you have that information memorized. Really, you could type it into your calculator and it'll tell you. I mean, if you get 0, then it's going to be 0. But if you get a number, then you're going to get 2 answers. The next one we'll do, the discriminant is going to be 0. Spoiler alert, I'm sorry. So we don't have 2 solutions because there's nothing to add or subtract. Sully?
Good question. What was the equation we were using earlier about the vertex or
The quiz? Is that a quiz? What did you say? It's negative b over 2a. Negative b over 2a.
second thing, the 2 points put on the graph, those were done earlier?
Yes.
Okay.
All right. Go back to the other page, and now we're going to do the second one where you only have one solution. So this equation can be the A is -1, the B is -6, and the C is 9. So then we're going to use our quadratic formula. Negative B, which would be +6 plus or minus the square root of B squared, so -6 squared, minus 4 times A times C. All over 2A, but A is just 1, so it's 2. Now, let's simplify the discriminant, aka the number under the square root. So -6 squared is 36, minus 4 times 9 is 36. Since that's 0, we don't have anything to add or subtract here, so we just get x equals 6 over 2, or x equals 3. In cases where you only have one solution, it's because it doesn't cross through it twice. It's kind of like a tangent to the x-axis. It comes down, it touches it, and then it comes back up, like that. So on the next page, actually, let's write down our vertex. Our vertex would be still this negative b over 2a part, which is 3, because the square root part cancels out. And what's the y-coordinate of the vertex? Emma? 0. And part way to think about that is because we got 3 by setting our y equal to 0. The other part is if you plug 3 in for x, you would get 9 minus 18 plus 9, which is 0. So if you're not sure, you can always just plug it back in to check. But there's our vertex. Now we're going to go to the next page and fill in the middle column, which is the same equation. So if I just subtract these terms over, we get x squared minus 6x plus 9 equals 0, which is the same equation. The discriminant was 0 because our 36 minus 36, that canceled out. Since it was 0, we only had one solution because there's nothing to add or subtract anymore.
Thank you.
Bless you. And then now we're going to graph it. So that's all I need for a graph because it starts at 3, 0, and then it just goes up. The y-intercept C is equal to 9, so I need to go up 9 on my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Here, 56. 56.
Sully, did you still have a question from before?
I still don't know how that worked. It's just
really
like,
comes around.
I don't know how this graph gets you.
And it'll affect us next week when we relearn about completing the square. Because completing the square has vertex form in it. And we need that to write equations of circles.
We're just doing the same for algebra right now, basically.
Yeah, but we're applying it. They already learned completing the square, and we're going to review it next week before we start learning how to use completing the square to write equations of circles. Would you also need to do that next year in Algebra 2 when you write equations of other functions like ellipses and hyperbolas? Yeah. All right. Then one last one. So scroll up. How many other types of solutions can we have?
0.
Yes. 0.
What? How is there 0 solution?
What? Because there's not always a solution.
Alex, look. Look at the orange ones I have on the board. They come down, they don't cross through though, they just go back up. Or it can go, are you looking at the right spot? Right here.
Oh, that one on the bottom.
Nothing expanded.
He's like looking up.
I wish the viewer could see that.
Yeah, it extends, but it extends down or extends up. It doesn't cross through the x-axis. These solutions are imaginary. Okay.
Great, now there's
But we're not going to be doing imaginary solutions this year. Not till next year. Yeah. All right. So here our A is -1, our B is 2, and our C is -2. So The particular combination of A, B, and C will cause the parabola to not have any solutions, and we'll find out how that is using the quadratic formula. So x equals fraction bar negative b, which would be negative 2, plus or minus the square root of b squared, which would be 4, minus 4 times a times c, all over 2a, which is negative 2. Let's simplify it. So x equals negative 2 plus or minus the square root of, what is 4 minus 4 times negative 1 times negative 2? Well, I see two negative signs here. I'm going to cancel them out. And then I get 4 minus 8. You said 3?
No,
3? I said 3.
4 minus 4.
That is the most.
We're multiplying here.
That is very, very.
Okay, anyways, so 4 minus 8 is negative 4. So our discriminant is negative 4, all over negative 2. Well, we know that you can't take the square root of a negative. That would be no solution. So that makes the entire thing no solution.
Wow.
So since this cancels out, it's no solution. If the discriminant is negative, if you get a negative under the square root, there's no solution. If you try typing it into your calculator, you would get an error. Non-real, no, it would say non-real answers, not syntax
How are we
error.
gonna graph this? Miss Millie, how are we gonna graph this exactly?
Oh, but the good news is we can still graph it because it still has a vertex and it still has a y-intercept. So what is the x-coordinate of the vertex? What's negative 2 over negative 2? 1. So then we plug 1 back into the x up here of our original equation to find the y value of the vertex. So don't use your calculator. Negative 1 plus 2 minus 2. This negative sign does not get squared. It's part of the equation. The other class was confused about that. And then this would just become negative 1 because the 2's cancel out. So 1, negative 1 is our vertex, and the c is negative 2. Sully?
How did you find the y for vertex?
I just plugged 1 back into x. So negative 1 squared is negative 1 plus 2 minus 2.
How did you find c?
It's just the c. Yeah, it's just the c. So that's your y-intercept. All right. So now the first one, the one on the first column, if I subtract the 2 over, I get negative x squared plus 2x minus 2. So that's the one that we were just doing. The discriminant was negative 4. And since it was negative and you can't take the square root of a negative, that makes the whole thing have no solutions. So 0 solutions. But we can still sketch it. So let's do that. So I'm going to make my x and y axis. I only need to have 2 points for this one because I need the vertex, which is at 1, negative 1. Right there. And then I need the y-intercept, which is at negative 2. Right there. And then it goes down like that. Yes. It's the c. C is part of the equation. It's the last number in the equation. Because when a y-intercept is when x is 0, and if you plug 0 in, the x squared and the x would cancel out, and you would just get c. Okay. You guys good? So how about, since this is a video, we can practice number 1 together. Both pages are homework due on Monday. I'm going to pass out some graph paper so that you can use that to help you graph them.
Can I keep showing them my drawing? I'll show them my drawing. Video.
No, you problem 1. Get started. Get started on it, please. Okay,
Can you show them at least? Oh my goodness, you guys are all fiends. Yeah, you're after. You gave me 5 easy graphing. That's probably why. Oh. How you showing me that?
Okay. Let me. Should I do sticks now? It's okay. We'll just do it. All right. So since we have some time, let's do this one together. So x equals. Just start just using the formula, because if you feel overwhelmed, just use the formula. Negative b is -4 plus or minus the square root of b squared, which would be 16, minus 4 times a, which is 1, times c, which is 2, all over 2a, which is 2. All right, now I'm going to simplify it. In theory, you could just type this into your calculator right now, but I don't know why. I just like to have it simplified because it does help me check your answer if you just simplify it. It's not that hard to do. -4 plus or minus the square root of 16 minus 8 is 8. And simplifying at least the square root part can help you know how many solutions you're going to have. So if you get a negative number, then why bother with the problem? You know, why bother typing the whole thing in? Just at least type in the square root part. Like you could just type in 16 minus, like, not that you need to, you could do it in your head, but all over 2.
Please report to the office.
Grady?
Again, any 8th grade students participating in the field trip with Miss Faith, please report to the office at this time. Thank you.
You mean this -4 or this one? The first one?
I think I might be participating.
Okay. So now I'm going to type this into my calculator.
Maybe.
So -4 plus square root of 8 over 2. And I get -0.59. And then I'm going to get my other solution and also the vertex. So I go up, change the plus to a minus, and I get -3.41. So those are the main answers, but now I need to find the vertex so that I can graph it. What is the x-coordinate of the vertex? -2. And then it's the negative b over 2a part. It's this part right here. Okay, then I'm going to plug -2 back into the x. So x squared plus 4x plus 2. So -2 squared plus 4 times -2. You probably do this without a calculator. And then it's -2. Oh, it's +2. Sorry. It's +2. Yeah, you're right. It is supposed to be -2. So -2, -2. Yeah, you shouldn't need one. It's just 4 minus 8 plus 2. Yep. Then you need to graph it. Okay. Yes, you have to graph it. So I know the bell's gonna ring, but you're gonna have both zeros on this side, like there and there. The y-intercept is 2. The vertex is somewhere over here, and then it should look kind of like that. Okay. All right. Have fun. Homework is due on Monday. Show all your work. Don't forget about your graphs if you want to, like staple.